I'd like to now talk about some application problems that have to do with what we call bearings. Both airplanes and ships use bearings basically to tell direction from one point to another. Let me draw a situation here. All right, first of all, on bearings, straight up is north, straight down is south, to the right is east, and then to the left is west. And then basically here, you're still thinking about the positive x-axis or the east axis here as being your initial side. Let's say that you have a terminal side in here somewhere. Now, the way that you measure a bearing is different than the way you measure a standard angle in standard position. In other words, this particular angle, let's say that the measure from the north to the terminal side is 32 degrees. And so the way that you would measure this particular bearing is you would say from the north line, I go 32 degrees towards the east line. Okay, let's consider an angle maybe over here. On this particular angle, we could measure a bearing. Let's say that the angle inside of here was, I don't know, 65 degrees. This particular bearing would be from the south. I go 65 degrees towards the west. And so what you'll always see on a bearing is you will see either a north or a south first, and then it will tell you a degree measure, and then it will tell you towards which axis you're swinging the side. Let's consider one other. Let's say that you have something along these lines. There's two different ways we could measure any of these angles, actually, at least two. Let's say that we have an angle here, and let's say that that angle all the way around is 115 degrees. Okay, one way to measure this is to say, I'm sorry, I had this misdrawn. Let me see if I can correct this for you. Okay, you never measure a bearing from an east or a west line. Let's say that the measure from the north line around to the angle that we have there is 115 degrees. All right, and so what we would say here is we would say that this particular bearing is from the north 115 degrees towards the east. All right, now the problem with that is normally bearings are given so that you have an angle less than 90 degrees in between the two directions. And so that being the case, what you can do to fix that is you can say that you can measure that bearing from the south line. If you did, to measure the bearing from the south line, you would say, okay, the measure all the way around from north to south would be 180 degrees. If you took 180 and subtracted off 115, then you would get 65 degrees. And so what you can say instead of north 115 degrees east, you could say south 65 degrees east, and those two bearings would be the same value. All right, so this is the general way that we measure bearings. The things that you have to remember is number one, always measure a bearing from either the north line or the south line. And then number two, always make sure that you're telling which direction your angle should be rotated towards. Is it rotated towards the east line or is it rotated towards a west line? And then finally also, like I've made the point here on this last piece, if you have north 115 degrees east, that would normally be rewritten as south 65 degrees east. The other thing is we don't measure negative angles. We always use angles between 0 and 90 as standard form for bearings. Let's look at an example here. In this example, it says that an airplane takes off from the airport at a bearing of north 20 degrees east. After flying 1 mile, the pilot makes a 90-degree turn and flies towards the northwest. After the plane travels 2 miles, what is its new bearing? Now, this new bearing that they're asking for is always going to be from wherever you started. So they're saying here you started from the airport, and that's the bearing that was originally given. And so this end question is understood to be from the airport as well. All right, so let's draw the situation first of all. All right, draw a north, a south, an east, and a west line. Let your original location be the origin. So we're going to let the origin be the airport. Okay, the original bearing, it said it was north 20 degrees east. And so from the north line, we're rotating 20 degrees to the east. And so the measure in here is 20 degrees. All right, now it says that the airplane flew 1 mile on that bearing. Okay, then it says the airplane took a 90-degree turn, and it said that it took a 90-degree turn and then flew northwest. I could either have a 90-degree turn this direction or a 90-degree turn that direction, and I need to be able to determine which direction my 90-degree turn is. Because it said northwest, then I'm able to determine that it's this one. All right, now from there, it said that the airplane flew 2 miles. And so what you'll want to do is you'll want to extend that until it's about 2 units. So there's 2 miles in that direction. Now the final question is, what's the bearing after you have flown 2 miles? So they want to know a new bearing. Now this new bearing, do you see, is going to be north, however many degrees west is going to be the new bearing. So I need to know north, how many degrees west. Okay, well, to do this, I'm going to solve this right triangle. If I can figure out how much total this entire angle should be, then I can subtract off the 20 degrees that I already know to find out the angle that I need. I tell you what, let's let the angle that we need be beta. And so down here, this is going to be north beta degrees west. Let's let this entire angle be O for the angle at the origin. Okay, let's solve this right triangle and see if we can figure out what the angle at the origin is. Okay, to do so, I need to use an adjacent and an opposite side because the 1 mile and the 2 mile is what I've been given. And so on this particular one, I'll use tangent to find O. So angle O, I find by using tangent of angle O, and maybe I'll put a little curlicue on it, that way I'll know that that's not a 0. So the angle O is opposite, which is 2, over adjacent, which is 1. Alright, that's the same thing, obviously, as 2. And so to solve this, I need to take the inverse of both sides. And so this would be angle O equals, and then I can plug tangent inverse into my calculator. That would give me 63.434948882, and that's in degrees. Now, here's the problem with this particular situation. There are certain situations where you can't avoid using a non-exact answer. So right here, this is not exact, but I can't avoid using it again. Okay, so I'm just going to put that note, can't avoid using O again, so it's okay in those situations to use it over. Alright, what we want to find from our picture, let me scroll back up here, so we've found our whole angle at the origin. We want to now find beta, and so we can see that we want to take the angle that we just found and subtract off 20. So beta is going to equal 63.434948882 degrees minus the 20 degrees. And so that would end up giving us here 43.434948882 degrees. All right, from up above, remember that we had said that our bearing, because of our picture, is going to be north. Whatever beta is, west. And so now we can say our final bearing that they ask for is north 43.434948882 degrees to the west. And that would be our final answer. This concludes this lesson on bearings.